Okay, so circles can also touch internally at a point, as you can see in this diagram. So if a circle is contained within another circle, in other words, is occupying the same space, they can still touch, and this relation is true here. Okay, so in this case, the distance between the two centers of both circles will equal to the difference in the radii. Okay, and if you look at it, okay, if you think about it logically, that will make sense, won't it? Because if R2 represents the radius of the larger circle, okay, so let me draw that in there. Okay, from the center of the larger circle there will be R2, and then the radius of the smaller circle going from there to the circumference there will be R1. Okay, while of course then the distance has got to be the difference between these two, isn't it? It's got to be the bigger radius, take away the little radius, is the difference. Okay, that will be the case here. So we can use this. Okay, if they say they touch internally, we can use that formula, or sometimes we have to use it to prove that they touch internally if that actually occurs. Okay, so let's look at an example. It says here two circles C1 and C2 touch internally at a point with circle C1 contained within circle C2. So it's a bit like what we just seen in that diagram. Circle C1 has the following equation. If circle C2 has center 2, 1, find the radius of this circle. So let's focus on C1 to start with. Now we need to know the center of that domain and the radius, and of course we've got to rewrite this in this sort of standard form to work out the center. So group the x squareds and x's together, group the y squareds and y's together, okay, and then complete the square. So we complete the square here, well, we halve that domain, so we get minus 2 bracket squared. Take away then the square of this, and the same here then, we halve that, take away then the square of that, and then minus 1 at the end. So we get x minus 2 all squared, y minus 2 all squared, and then minus 4 minus 1 is minus 9. So take it over to the side, you get 9 there. So for circle C1, okay, the center is 2, 2, and the radius is this, obviously that's r squared, so the radius will be 3. Okay, now for circle C2, the center will be 2, 1, and the radius R2, well, we don't know what that is, don't we? Okay, so it's a question mark. What is R2? We don't know. Okay, so the fact that they touch internally, though, we can use this formula then. So we can say, look, since they touch internally, okay, and C1 is contained within C2, D will equal to R2 take away R1. Okay, we've got exactly that situation. So let's go back to it again. This is the situation we've got if they touch internally. The radius of the larger circle there, okay, if you take away the radius of the smaller circle, you will get the distance between the centers. Now, we've got to work out the distance between the centers. But you know what? We don't have to do much work here, because the center of C1 is 2, 2. The center of C2 is 2, 1. Okay, so it has the same x value, okay, but this is one value higher on the y-axis, yeah? So the x values are the same, the center is just one value up on the y-axis, so the distance is just 1. You can use Pythagoras to check if you want, but D is going to be 1. R2 we don't know what it is, and then of course R1 we've got 3. So if we then take that over to the side, we get our R2 to be equal to 4. Okay, so we've got the radius of the second circle to be 4.